Welcome back to WP Development's YouTube channel. It's been a hot minute since I've been on here. We've been super busy with growing the business and new designs and developments that we've been working on under closed doors here. One of the things that we wanted to bring to you guys today is the fact that we are starting to do torque converters in-house here at WP Developments. So there's a couple topics I want to reach out on and kind of tell you some of the factory failures. What is a torque converter? How it works? What is a torque converter? Torque converter is part of your transmission. It is driven from the engine. It uses fluid and basically propellers to throw from one side to another to drive your input shaft, which your input shaft is what drives the output shaft. So in short, that's kind of what a torque converter is, and there is a lot of different things that happen inside that torque converter and a lot of moving parts and a lot of reasons why they fail and why some companies have really good success and some companies do not. You know, I talked to a lot of people in this industry that it was very hard to get into, for the fact that, you know, if any of you have tried to rebuild with a DIY kit or something like that, you know, you got what they call an ATSG manual, or there's a lot more people that have been inside of a transmission to help you rebuild it. But unfortunately, it seems like the torque converter rebuilding era was, you know, some of the older generation guys that really dug in deep with them. And you really have to reach out and grab those guys and kind of take them to the side and get some of the tips and tricks, because there isn't a book per se that you can read. Sonex is a great asset to our company. We do a lot of business with Sonex. We help them with a lot of things. They help us with a lot of things. They've been great to work with. Garin, Garin Brothers is a huge outfit out of Iowa. I'm sure most of you have heard of them. They have been a great asset to us. Matt Brooks at DNP Torque Converters, you know, he's a veteran at this stuff. Just gathering information, bits and pieces. FTI is another one that we've been in contact with and bought parts here and there. And you know, we got in the groove. We did some testing. We got one in our Pro Street truck, doing excellent. Testing out different, basically power levels and what we need to do for different power levels. As in, you know, that's one of the topics we have here is stall ratios. So, you know, the stall is, if your foot's on the brake and you're giving it gas, like how much RPM are we going to go up? How fast are we going to build boost depending on turbo size, gear ratio, tire size, stuff like that. So depending on what you're trying to do with your vehicle would be the definition of what stall rate we would go with. So a lot of our typical questions for you know, speccing out a torque converter here at WP Developments is, hey, what size of turbo do you have? What is the purpose of the truck? Is it towing a trailer every day? Is it to go out and have fun, do burnouts, stuff like that? How big is your fuel injectors? That kind of gives us, you know, turbo and air, or air and fuel are two of the key factors that we need to know, just so we can say, okay, well, I've built one like that. That is an 800 horsepower setup. So there's the lockup clutch inside there. That's how you get a 1-to-1. So as fast as your engine's spinning, your input shaft's spinning. So an unlocked torque converter is going to rely on your stall ratio. So when we go into, say, a super stock or a 650 series 68 RFE per se, that's, you know, 650 horsepower and below. We have a really nice triple disc setup. That's an upgrade on the super stock. So we have a double disc setup for the typical super stocks. Don't want to false advertise there. But our 650 series is going to come with a triple disc. Unless there's somebody that has some sort of crazy setup, those all get what they call a 15SS stator. That stator is basically telling us that it's a 15-blade stator. It is very, very efficient, meaning it's not going to want to give you a lot of RPMs before it starts taking off. So when you drop it and drive, that thing's going to want to try to pull away from what you're doing if your foot's not on the brake. So your engagement's going to be pretty firm. Um, so the reason we do that is the 650 series is built around a lot of the workhorses, right? So you're towing your boat out of the boat ramp. We don't want a big high stall converter where your RPMs have to be at 3,000 RPMs to pull up out of the boat ramp. It's the same way with a skid steer on the back or an excavator or anything in that nature. Now that stall cannot go into something that's 1,000 horsepower that you're going to be sitting on the brakes trying to do a burnout. It will create so much heat because it's trying to drive through it and shearing the fluid that it will end up either laying over the fins or creating so much torque multiplication in there that it will start building a ton of heat and you will melt things down. I've done it. I've tried it. It doesn't work. Don't do that. So one of the most important key factors, I guess, is what I'm saying is when you go to buy a torque converter, whether it's from us or somebody else, just make sure the manufacturer that you're using understands what kind of abuse you're going to put this thing through, what you're doing with the truck, if you're towing, if it's a toy, if it's on the drag strip or your sled pulling, or just out daily driving. You know, that those things are something that every torque converter manufacturer needs to know. And that's where we start getting into our stall ratios. So our stall ratios, like I said, the 15SS is a very, very tight stall. It's considered a lower than stock stall. The stock stall in the 68 is a pretty loose stall, something with quite a bit of horsepower. So we put it in perspective, like our Pro Street drag truck, it utilizes the same stator design as a stock stall 68. So that kind of horsepower matched very well with the stock stator design. So once we get into the stall ratios and get that figured out for everybody, then it becomes into what power level are you going to be at? And that's going to start determining, you know, how much fluid coupling is going to be there. They all will be a triple disc converter on the 650s and up series from here. So we don't really change the lockup clutch assembly. There is another thing in there that I haven't put on our board, which is called a dampener. That dampener in torque converters takes the shock load when the lockup clutch hits. That dampener is going to start compressing springs and dampen the shock load going into the transmission. This is what's going to save like input shaft or hard shafts, you know, so it's not such an abrupt jolt to the drive line. Those are very important, and especially in the 68 RFEs. Any non-dampened torque converter in there, you are almost guaranteed to break something hard part wise. They are very violent. Um, how does it work? We kind of touched base on that a little bit early on in this video. Um, the torque converter will basically, the pump feeds into the torque converter. The torque converter picks up that fluid and starts pumping it. What it'll do is it'll go around the fins. It'll start multiplying the pressure by doing the radius on the fins and blowing it into the turbine. Once the turbine catches that fluid, it's like if you would blow on a fan blade. You know, the harder you blow, the harder that spins, the more power it's getting into the transmission. There is a point of where the stator inside there is on a one-way sprag. If you haven't watched my video of Sprags, it was a video I did a couple months ago. Actually, one of my first videos for this YouTube channel. Very in-depth, very, very knowledgeable. You can gain a lot of knowledge from that. And that's the same type of concept as, you know, the low roller sprag in the 68 RFE. The torque converter also has the same style sprags. So there's a roller sprag, there's a dio sprag, there's spragless. There are dog bone style sprags, which I explained. And the duty of those is once it hits its efficiency and it's, you know, it's starting to actually overrun what that stator efficiency is, it can go into a freewheel. So when it's in freewheel, it doesn't need extra pressure. We've already reached our 1-to-1. So what happens is you'll hit that sprag trying to brake stall that sprag, like on a hard launch. I'm sure some of you have had a failure to where it feels like your lockup switch was stuck on and it kills the truck when you come up to a stop sign. And no matter what you do, reverse and drive, when you start the truck, put it in gear, it'll stall it out. That is typically the sprag in the stator. So if that sprag locks full on by being caught or ruined in the races, it will be in a full lockup state and it will stall the truck out. Sometimes what will happen is when you shut it off, it'll actually jolt that sprag enough to make it freewheel again, and you'll start it up and it'll work fine until you get it under a heavy load again. I've had multiple ones do that. That is that sprag getting stuck, come up to a stop sign, and it kills the truck. Some of the things we do here at WP Developments, we really concentrate on the failure side, right? So we take failure analysis in, what we've seen in the past, what we know about other sprags and how they work, and we make them better. So we have updated all of our sprag races to a brand new sprag inside there. Um, we do a hardened aftermarket race inside there for the sprag to ride up against that has built-in spring locks. So that being said, we're doing all we can to keep that stator and the sprag assembly from failing under high abuse or normal wear and tear. So as you sit there and that thing freewheels or that locks so many cycles, it will eventually fail. So we try to use better material, brand new rollers, brand new return springs, brand new inner races on all of our units. We will not skimp out on that. My goal when we started this was to make something of quality, and it might not be the most budget friendly, right? Like, we're not, unfortunately, we can't make a cheap one and make it good at the same time. So we sacrificed a little bit of, being cheaper for a better quality. So some of the parts that we put in there aren't typically in competitors' torque converters that you would normally buy. We tried to go as far as we can to make that as brand new of a torque converter as possible. So that was our goal. So and we've achieved it fairly well. There's some things of a core that we simply just can't get away from, and there's some things from a core that we absolutely just will never look at again. We just throw it in a scrap bin that maybe some other people would use. I'm not sure. So the different power levels is we start out with a what we call the double disc. So Sonex made a double disc converter. That's your typical heavy duty torque converter. So that's not something that's going to see technically any extra power. Some people will put 400 horsepower, 450. Some people will stretch the limits to 500. I'm sure. That's going to be like our lowest grade of torque converter. That's going to come in like the super stock, like we talked before. And then once we move up from the double disc, it's called in the 68, it's called a 681 here. So that's going to be paired with our 650 series. So the 650 series is designed and developed for workhorses, farmers, construction workers, families out there pulling their big campers, up the mountainsides, stuff like that. That's kind of like it's a budgeted 800 series that, some of the knickknacks that are in the 800 weren't needed for somebody out there, doing construction and doing the farming thing and doing the pulling the camper. So the 650 series does get a part number called the 681. And that torque converter is always going to have what we consider the 15SS stall rate in it, which is a tighter than stock stall. And it's going to have all the updated, it's going to be a triple disc. It's going to have all the updated sprag races and rollers in there, as well as brand new bearings. We are actually prototyping a new turbine hub, which is what basically your input shaft splines into. Maybe I'll give you a little sneak peek of that. We worked with Garen, gave them the idea, and they did some machining for us to kind of help with some other failures that we've seen, in the industry. So we go from the 681 to a 682. The 682 is going to be like our 800 horsepower series, and that is another step to our torque converter game, and we're going to kind of keep that in line with, the 48 REs, the 47 REs. We'll still do this stuff for our 10-speed stuff, which we are getting into. We're doing some 6R140 quad discs stuff in house now. So we're dabbling in a little bit of everything here and getting our build processes and testing all in done in our in-house trucks here. But the 682 for the 800 horsepower series is basically saying, okay, well, a 15 SS probably isn't going to work. This is something with a little extra horsepower, and we're going to need a little looser stall. We're going to need an HD sprag race so it doesn't rip it out, during brake stall. This thing's going to see some abuse. So it'll go through and start. They do furnace braze, what they call a furnace braze, in the factory platform. That furnace braze is all the little fins that are in the covers, and they basically stick like a piece of brazing rod in there, and they stick it in an oven, and it melts and it flows in, to keep the fins from being able to pop loose and fold over. So the harder you are on a torque converter, the more easy it is to fold them fins over. So once we get up into the 682 and the 683 part numbers, this is like a competition build, we're going to start furnace brazing each one, hand brazing each fin in there to keep that during brake stalls and stuff like that from folding those fins over under high pressure possibilities. So those are kind of like 4 different stages that we're going to offer to you guys and continue to develop new things. Obviously, there's always room for upgrading as time evolves, and getting somebody new into the torque converter game is always, I feel like, is always good. Different set of eyes, different ideas, and bouncing that stuff back and forth between a lot of different companies and asking why haven't they done this yet. And that's kind of always my train of thought when I get into something, and face it with our team is I go in there and I'm thinking like, man, this stuff has been out for 20 plus years, doing this stuff. I'm sure by now everything is absolutely 100% perfected, and there's absolutely no room for us to improve something. But it seems like that's never the case. Like, you can always get a different set of eyes in there, and you can always find places to make things better, to cut down on failure rates. And I think that's how we're going to help this torque converter game evolve. I mean, that's what we're all about, is taking something apart, failure analysis. Let's see how we can make this better. Um, the uh, the stock failures, I mean, that is pretty simple. They are not designed to handle anything like what we try to do with torque converters. They are it's a single friction disc. Um, it does have some cool features to it that aren't designed into some of the billet front covers, like ball bearings. Instead of, the factory has a ball bearing in there for the turbine hub to ride on, versus the aftermarket option is a bushing. So we haven't seen one of those bushings fail, but I always like the ball bearing just because it's not going to wear ever. It's submerged in fluid, but I could see that being a problem if it did fail. Now you have ball bearings going through your torque converter and all of your pieces and going into your transmission, and then you have a bigger problem. Stock failure is just basically it doesn't have enough clamp force and enough friction surface area, right? So, as we the 68 alone is what they call a PWM lockup. So, something that the factory has been doing for quite some time now. That's for shift feel. So what they will do is they'll slip that lockup clutch in and out. And after so long of slipping a clutch in and out, it just bites the big one, right? Like, the more you slip it, the hotter it gets, the more it sheds material. And after so many cycles of on off, um, it just eats itself. Uh, the other failures that we see are in the Sprag. Um, the uh, the rollers inside the Sprag, those we do see fail. We update the also the Sprags to have they have a Sonex um, cast aluminum plate that goes on the back of the Sprag instead of a poly retainer from factory that does not retain a bearing. So now we have, everything rollerized in there on the stator itself. It doesn't create as much heat. It doesn't have a failure rate like that poly does, from the factory. So that's one of the factory failures that does get updated. On top of, obviously, we add a it's 2 disc, 3 friction sides. That's what they consider the triple disc. That's pretty. That's across the board. That's nothing different from most people. But some of the things is kind of on this. We're gonna have to walk out to the shop and kind of show you hands on. Some of the things that we talked about here. Um, on basically like the Sprag, so you kind of know what that is and what we're talking about. Um, some of the proprietary stuff that we're doing different than other people, prototypes and stuff like that. So we decided to step out into the shop and kind of show you some of the things we were talking about here. Um, First thing I'd like to touch base on is the heavy duty Sprag races. So this is your stator. Okay, this is how we get different stall rates on. There's a lot of variables on stall rates, but the typical stall rate is going to be based off of your stator. So one way you can see this thing spins, and the other way it locks up. That's a Sprag. It's a one-way freewheel, kind of like your ratchet, when you go from on to off. These Sprag races here, this is an aftermarket heavy-duty one that we use in our higher performance builds. And then we have another one here that is factory. So the factory one it's kind of a 2-piece deal, and these are what retain the little accordion springs. Those we have seen start to flex and break and not create the Sprag rollers themselves to start evenly on the ramps, which I said before in the video, if you haven't watched my Sprag, how they work and everything, that might be something. If you have questions on how the Sprag works, that would be a really good video to go watch. Basically, it takes these little ball bearing ball rollers here, and it will shove it up the ramp to where the inner race and the outer race are locked together, and it cannot spin any further. So we can freewheel one way, and then when it goes the opposite way, it pushes that little ball bearing up the ramp. That grabs it, and everything spins in unison. So there's a lot of pressure trying to force this. There's a lot of duty on these spring retainers. So when you have them that are a one-piece, milled in, billet, hardened, the ramp rates are a little bit different to help grab and not get stuck. That is a big update to keeping these things alive and keeping it from brake stalling like we talked before. Another thing that we do, I kind of explained earlier, was these are Torrington bearings. So these are little cage bearings that everything spins on. The factory would come with one that looks like this. So this is just a poly, basically bushing per se bearing, and it has a Torrington on one side and this poly on the other. So one thing that we do is we update the stators to have, Sonex makes these, by the way, for us, and we make it a metal piece here, and then that allows us to put 2 Torrington bearings in there, and that makes it a more drag free, so it spins easier, which would create less heat. This is a better setup. It retains the cage in there a lot better in the Sprag. That is a very important deal for Sprag is to make sure those needles in there are not able to move up and down, and that is a for sure way to keep that from happening. So every single stator that comes out of here for our torque converters gets the updated retainer there. We talked also about this in the video in the office there about furnace brazing. So on these, this is a factory 68 RFE front pump half, and these fins in here are what basically throw the fluid to start making it go forward, right? So when you get into high torque, high stall efficiencies like brake stalls, burnout, stuff like that, you have a lot of pressure against these fins. And so what we will do is we'll go in here, and for our competition 800 series, we will actually start brazing every single one of these fins on both sides everywhere we can to keep those from moving and creating a layover effect. If these lay over, all of a sudden your torque converter pretty much quits working. It's a very high stall. It's very inefficient. The harder these lay over, the less fluid pressure they make when they're turning. So if you ever get into a spot where your torque converter seems like it's gaining stall, probably what you're facing is the fact that these fins are starting to lay over. It's becoming more inefficient, and it's creating your stall rate to go up. And that's also something that some of these guys are doing for competition builds, is they will sit in there and they will bend every single one of these fins and create to be less efficient at a certain area to get that stall rate off the line. If you're drag racing, sled pulling, and something like that, to basically get up on top of the turbo or whatever you're trying to do there. So another thing is, these are the walk-up clutches, very big. We have personally put around 2,600 horsepower to this amount of friction surface. Same friction, same material. This is the same material that we use inside of our torque converters. It's an alto material. It's a very, very rigid material. It's a carbon lining. They do very well. They hold up to a lot of heat. They even have what they consider the choline coating on them to kind of keep them hardened on the outside so the splines don't wear. This is a very typical triple disc lockup clutch. Very big, 3 sides. So you have 2 frictions, but 3 sides. So that's why they call it a triple disc. The other thing that we are working on, that we have some prototypes here, is some of the issues we've seen is the input seal. So if you look down at your torque converter, it's going to have an input seal inside there. We have seen these become dislodged. Sometimes it's from driving the seal too far in past their recess, and it deforms the seal and doesn't grab all the way around on the seal. Sometimes it's just the flex of everything, so everything kind of wiggles in there, and after so long this thing can wiggle its way out of it. So what we came up with is a snap ring groove. So once you press this seal in, there is going to be a retention snap ring that will not allow that seal to come backwards. It can't come forwards because there is splines in there. So it cannot dislodge itself forward. There's also an input shaft that splines into there, and this is what seals the lockup clutch on the front of your input shaft. So this seal, like I said, these are some prototypes that we gave the idea to Garen, and he sent a couple prototypes for us. And these are going to go in some of our trucks that we're going to try to put a ton of miles on and make sure this is working. And we know that if we have a snap ring in there, this seal cannot dislodge ever. And that's, if it's even 2 a year, I don't want the opportunity, right? So it's not a huge, I would say, failure rate on these, but it does have a failure rate to it. So instead of waiting on 2 a year to come to us, we wanted to make a fix that would be a positive fix that we knew would work absolutely 100% perfect. So that's some of the stuff, in our build area, kind of help explain some hands-on stuff of what these parts look like that are going in there, how they work, what we're doing a little bit different. What we're concentrating on, obviously, is trying to get a better unit out there for our customers and be able to take our turnaround times down, and not wait on torque converters. So, it's been a hard task to take on. Like I said, we don't have a book to go off of. We really rely on a lot of the older gentlemen that have been doing this for a long time, and thankful they are willing to give out information and kind of help us with the small questions we have. I mean, as much as just saying, how thick should this torque converter be, because we can measure torque converters all day long, but, factory versus aftermarket, they do have different stack heights. And where can we be? What's our minimum? What's our maximum? Custom tooling that we had to make ourselves. It takes a lot of time and research and development. Probably haven't seen me on the forums a whole lot lately, and this is why we've taken on so much as a team. We're adding more people on to stay in torque converter building and machining and welding and keeping that thing alive. And there's a lot of hands-on to it. And so I have been kind of away from the social media platform a little bit. I try to pop in there every once in a while and answer all the questions I can. But if you wonder where I've been, it has pretty much been right here. Getting our processes dialed in, set up, ready to sell. Obviously, we're putting them in all of our units, and we have been putting them in our test truck, the Pro Street drag truck, all of our daily drivers, and we've been pushing the absolute limits of them and making sure that everything that we're doing, we're seeing as a benefit and something that's hopefully a better product over some of the others that are out there. And that's our goal for this process. This stuff should be online on our website very soon. I know we've all been working hard at getting the pricing together, getting it, product imaging and stuff like that. We have some internal structure stuff that we're working on as well for keeping our inventory up to date, and so we can keep on the demand. Hopefully the next video we can get something together for you guys. Make sure you put in the comments what you want to see next, and we'll do it.